So let's see how we can declare these variables that can hold up decimal places. We're gonna go right here in this onCreate method, and let's start with the declaration part. So I'm gonna leave a comment right here, declare variables. And so we're gonna have first of all the float keyword, which stands for floating point numbers, and they can hold up decimal places. And I'm just gonna give it a name, let's say price of item, and this can be just like that. Just gonna leave the declaration as it is, and then I'm gonna use the double keyword, and I'm gonna explain you in a moment why they're different. And just to give an example, we're gonna say TV screen in inches, so basically the diagonal of the screen. And I should rather specify TV screen diagonal in inches. And so as you can see right now, float can have 7 decimal places and double can have 15 decimal places. And so that's why it's called double. And there's also one more reason I'm just going to show you in a moment. First of all, let's see how we can initialize them. And I'm going to use first of all the float keyword. And so in order to give you an example, we can use something from geometry. Let's say side of triangle. Okay, and we're gonna have, let's say 12.55, and we have one error right here, and it says incompatible types. I'm just gonna zoom out a bit so you can see it. Okay, so it says incompatible types, required float found double, and this one is considered double if you just leave it as it is. If you specify an F at the end, then it's a float value. And so let's see how we can do this by typing double keyword, and we're gonna have something like a percentage. Let's say grade obtained in assignment, and so we're gonna have, let's say 70.50, and as you can see it just works like that. It's the same thing as just 70.5. And I'm just showing you that you can also have, now this is not the best example, but you can have also negative value. I know the marks cannot be negative, but just giving you an example. And you also can have, for example, 0.5, or you can have only 0.5. It just works as well. So these are just some ways to initialize them. And so I'm just gonna keep 90.5 for this grade. And also keep in mind that for floats, they just keep 4 bytes. So one variable equals to 4 bytes in memory, and if you allocate one double variable, they keep 8 bytes in the memory. So that's why they're called double, because they also have double precision, as you can see right here, more decimal places, but they also occupy twice more the space in memory. So that's the story behind the name. And right now let's perform some operations with these variables. And so we're gonna say, for example, we're gonna have for float, we're gonna have side of rectangle, or rather we can use something more practical. Let's say we have just one piece of lumber, and let's set it equal to 90.56755. Let's say it's in meters, and we're gonna also say that's a floating point number, and we're gonna cut it in different pieces. Let's say number of pieces that we want to have, it's gonna be so I'm just gonna, instead of using another declaration, I'm just gonna put it here in this float declaration. I can put as many variables as I want. So I'm gonna say number of pieces after cut, and we're gonna have, let's say 7 pieces. So we're gonna perform this computation. Let's say float, let's say size of one piece is gonna be this piece of lumber divided by number of pieces after cut. So let's say we have a chainsaw and we just cut this piece of lumber, and I'm going to display the result on the screen. So I'm just going to use this size of one piece. I'm just going to use this message, and I'm just going to attach the size of one piece, as you can see right here. And also I want to make sure that it's displayed a bit longer on the screen, so I'm going to use length long. Okay, and then I'm going to give you an example with a double variable. So I'm going to say something almost similar with this, but I just want to show you that when you divide some float numbers, you have a different precision than when you divide some double variables. So I'm just going to give you an example of 1 bar of iron, and so it's going to be set up to the length of, let's say, 120.8899056 meters or inches. Doesn't really matter right now. And we're also going to have another double variable, and we just want to make sure that we set it up to a number of let's say number of little bars after cut. So we're gonna have a tool in which we cut this this big bar of iron in several pieces. We're gonna have, let's say, how many pieces? We're gonna have 13 pieces. Just want to show you how it works. And in order to have this computation working, we just have to create another variable, and we're gonna call it result. And as you can see right now, we can also give it a more meaningful name. We can say, for example, size of one piece after cut. Okay, and it's going to be equal to bar of iron, so the initial length divided by number of little bars after cut, let's say 13. And so I'm going to also display this on the screen. I'm also going to get rid of this project view. As you can see right here, we're just going to click on it, and so we can see better all the things that we have right now. And I'm also using a toast message, and on this message I'm going to say size of one piece of iron, and it's going to be attached to this size of one piece after cut. And so just want to make sure that we display the different messages for these things. So I'm going to have float of one, so size of one piece, and I'm going to say of lumber, and it's going to be, I'm just leaving here in brackets just to make sure that you remember that this is a float variable. And for the iron we used a double variable, and you're going to see now the precision. So I'm just going to go right here and run the application, and we're going to see this displayed on the screen. And as you can see right now, we're going to have the size of the lumber with 6 decimal places for the float, and we have around 10 decimal places for the double variable. So it holds more decimal places. As I said at the beginning, it can hold, depending on the operation you perform, a double can hold 15 decimal places and a float can hold 7 decimal places.